Hi, kids. Okay. Previously, you guys we talked about a little bit intro to fluids, and we talked about how with fluids we talk about pressure rather than force because a fluid kind of fills up everything. So pressure is talking about, well, it's pushing all different ways, and so and we also talked about how if you go swimming and you dive way down, you feel all that pressure because all that water above you. So today I want to show you at a certain depth how you could actually determine what the pressure is. Okay, so that's where we're going today. So just like we did yesterday, we're going to start with a big pool of water. So here is my giant vat of water, and it's going to be full up to this level there. So this is my giant vat of water full of water, okay? And so if I wanted to figure out the amount of, let's say, the pressure at the top of this, well, what's pushing down on the top? Well, that would be the atmosphere, okay? So like, if at the top, you would just have the pressure be the pressure from atmosphere. But if we wanted to figure out, like, let's say we're actually going to do force, so let's say we wanted to do the force or the pressure at some random depth down here, okay? Well, if I wanted to figure out the force at this point, that force is going to be equal to the force at the top from the atmosphere plus the weight of all that water pushing you down. So if I wanted to find the force here, it'd be the force at the top from the atmosphere plus all that weight. So the force, I will call this, I don't know, this would be the top and the bottom. Okay. So if I wanted to find the force at the top, okay, remember pressure equals force over area. So the force is pressure times area. It would be the pressure at the top, okay, times the area. Well, the pressure at the top, for this case, it's an atmosphere. Okay, so it would be atmospheric pressure. So really it would be this, the force at the top is going to equal to atmospheric pressure times whatever that area is. Okay? If I wanted to find the force at the bottom, well, the force at the bottom would be equal to the force at the top plus all of the weight in here. So like the force of the gravity of water above you. Okay, so that's a big long, subscript, but it's the force of the gravity of the water above you. Okay, does everybody follow? Hopefully that makes sense. So if I wanted to do this, well, the force at the bottom is going to equal to atmospheric pressure times A plus, well, force of gravity, okay, is M times G. Okay, so let me just kind of do it like this. This is going to be M times G. Remember with what we said yesterday, instead of saying M, what are we going to say? Oh yeah, let's see. Density equals mass over volume. So instead of saying M, we're going to say rho times V. So this is going to be rho times the volume times G. Okay, is everybody with me there? Well, how do you find volume? Well, volume is area times, if I call that depth height, my H, okay? So that this would really be rho times my area times the height, so again, that's my volume, times G. Okay, so if you look, the weight of all the water above you is going to be equal to that. Okay, density of the water times the area. Okay, again, that area would be the surface area of the top times my depth, and then times gravity. So if I divide everything by my area, I end up with this force at the bottom divided by the area equals the atmospheric pressure, or if you want, I mean really it's the pressure at the top, plus rho g h. Okay. The reason I'm going to write it like this, rho g h, is this is sort of looks like mgh, you know, but so that really what this is saying, if I put it all together, the pressure at some random point, some random depth. So the pressure at some random depth is going to be equal to the pressure at some top depth plus rho g y, or rho g h, whatever you want to do. Okay, so that this right here would tell you how you would figure out the pressure at a depth. Okay, the pressure at a depth is the pressure at some higher point plus the density times 9.8 if you're on Earth times the height between those 2 points. Again, this would be the height between 2 points. This would be your higher pressure and so on. So, yeah. Hope that makes sense. Oh, hey, one more thing, sorry. This whole thing I should mention, okay, this whole piece right here, okay, that is what's called, it's called gauge pressure, okay. The reason it's called gauge pressure, and I think the easy way to remember this, if you take a tire gauge, okay, you know, so you go, you pump up your tire, blah blah blah, okay, and it's, let's say, 40 psi, okay, your tire is 40 psi. Really, the air inside your tire is not it's not, you know, like the absolute pressure, that's what this is, would not be 40 psi, okay, it would be atmospheric pressure plus this would be the pressure inside. So like your tire gauge is not telling you the absolute pressure, it's telling you the difference between the two pressures. So inside your tire, there's 40 more psi than outside the tire. Okay, so gauge pressure really is the difference between the two pressures. This would be considered absolute pressure. Okay? Bye, kids.